all things we are going to discuss, like, fiber optic cable, the JX, the RG45, the old cable, media access cord, maybe, the hub, maybe the bridges, all these things, they falls across in the physical thing. Physical mean the signal, all the binary transmission start from here, something like we will discuss all this. So please try to mute everyone. That will be better. Thank you. Okay, let me open a slides. Okay, guys, so we are at physical level layer. So what does it mean in OSAM model? So it's all about layer one. We say in internet model, we say this is again a level layer one. So we are only focusing on the transmission about the circuit. Circuit is, we will discuss, don't worry, the network circuit. Circuit is kind of, same thing like, if you turn on the lights, your lights will turn. If you turn on the lights, your fan will be on, something like this. There's some kind of circuit. Once you provide a complete pathway, so it will provide electricity to your electrical circuits and electrical appliances. Same thing is happening in our networking communication, like routers, like, switches, they all has to be complete circuits to transmit and receive the signals across this, yeah. Those transmission over circuits can be, categorized with physical circuit, with logical circuit. Physicals mean once we are definitive connection with the wires, like, let's say you are connecting 10 routers, 10 switches, maybe you are connecting 20 PC with one router. So we say this is a physical circuit. So why? Because anything connected with wires, so we say it's a physical circuits, like physical network. Logical mean, let's say we have a very, very popular, like, virtualize or simulator, maybe, software defined networking based circuits, like, maybe router. So what we are going to do logically inside of one circuit, we are going to create a lots of circuits as well. Like, some circuits can be programmable. So we can program, we can make one circuit here, one network here, one network here. So they can work independently. So we say logically means, so kind of, the transmission with logical way, like inside a physical machine, we can make different redundant instances of the circuit. It's again the same thing, transmitting from one to one, receiving from one to one, something like that. But this is physical, this is logic. Physical means connected with physical wires, that's it, yeah. So in physical layer, so normally what we are going to say, like we say, British Naval Connector, BNC. You might have used it. Maybe some of you have used, untwisted pair, like, the copper cable you are using to connect your router with the internet, something like this. So we are using shielded twisted pair. We are using to connect router with your computer, desktop computer. Mostly you are using wireless as well. Wireless is also using access points. We will discuss all these things. Sometimes you are connecting coaxial cable. I would say try to Google all these things. I have provided this twisted and twisted, coaxial, fiber optic, everything you need to learn, please. Yeah? These must be in your coursework number 2 as well. So I would say all the information must be provided in coursework 2. Whenever you're creating something, you need to add all these things, like which cables you are going to use as a physical layer we are covering. So you need to mention, like, maybe for the coursework number 2 as a group assignment, the student, let's say, I will use some fiber optic, I will use some, STP cable to reduce the cost. So you need to mention exactly which model, which speed, which latency, which breakthrough you are going to cover. All these things you must mention, please. Yeah. Okay, guys, so let's talk about the circuits. If you can check the picture here from server to clients, we have discussed very, very detailed last time, like, client server architecture. So I'm now going to go again. Can you check the server is connected with client? So a message, a complete journey from one side to other, or from sender to receiver. Or you can say a complete journey from client to server, and server to client is known as a circuit. Circuit means a pathways of communication. What kind of pathway? What circuits they are coming to? So what they are doing it here, what they are committing here. It definitely networking in BDCN, we say business data communication. There's just only few things happening, like, kind of, audio, video, multimedia, that's it. So audio, video, whatever you are going to transmit is a circuit. So we know this is entire journey of the circuit. So we know this is circuit, physical circuit. Okay, so can be like, point to point, multi-point, something like this. So point to point mean once you are using very cheapest and very, very locally connection, like inside the same building, inside the same room. So you can connect circuits. Circuits means a simple network, you can say. Or you can make direct connection, which is less than, 50 meters. So I would say you can make just point to point, yeah. Something like multi-points means, so let's say we have in BDCN more than 1,000 students. So what will happen if you are come to in a classroom? You are capacity of 100 in each classroom, something like this. Yeah. So we can't give you like 100 cables to all of you, should not be possible. So what we will do, so we'll create a multi-point wireless access so everybody can come and access the internet and ULA, something like this. Yeah. So we are using multi-point circuit. I would say again, so please try to use multi-point circuit with wireless and point to point for some security, for financial thing, for management things. So please try to deploy all these things in your coursework too, please. Yeah, you will get definitive marks. Yeah. So that's why I'm just telling you. Okay, guys. So this is a very important. I'm going very, very basic way. Yeah? In because we have non-IT students, that's why we're just going on the top level. Yeah. And let's say the data flow, how data is flowing in the circuit. Let's say we cover the circuit point to point, multi-point, but there is some rule that data is transmitting across in different ways. Yeah. Simplex, halfplex, and full duplex. Yeah. If I'm asking, let's say, I'm not asking any question. This will make me some. Let me finish, then I will come discuss something. Simplex and full duplex. You might have been, let's say if you are using internet more than 20 years before, like, in older time, so you might be using the same internet, like, the telephone internet. So we say the dial-up modem. So you had a telephone at your home. So you were using telephone line and you were connecting with your PC as well in the olden time. So you were using a scratch card, a scratch is dial-up modem. So you were trying to dial up modem in the olden time. So might be, you are using same internet, maybe more than this old time, maybe more than 30 years. So what was happening? Our telephone was, almost based on simplex condition. Simplex means, someone was calling from Europe to Asia and Africa. What was happening? So guys was listening only, they cannot talk it up. So in the simplex mode, once they have talked, so they have listened. Now the listener can talk, so the sender will receive something like that. So it's just one direction, we can say. Very olden data transmission, we say data flows in just one direction. One guys can talk, one guys can listen only, and second guy can talk and other guys can listen. This is a way of transmission. It is very, very old system. So we are not using it now. It's oldest system. Okay, so this is almost out of our technology right now. But again, this is a kind of technology, so that's why we are going to do. Half duplex, it's something similar, but it's a little bit okay. We were using more than 20 years same telephone line. So we were talking, someone was talking, we were sharing, but once at a time, both direction, but once only at a time. Yeah. Right now, let me give you a good example of beautiful duplex. Yeah. Everybody is using, WhatsApp, Microsoft Teams. So we are using powerful application with kind of, decoupling microservices. They have lots of capable services these days. Let's say my WhatsApp, Facebook Messenger, FaceTime, all these things, they are part of, full duplex. Why? More than 20 students, they can talk on the same line, and more than 20 students, they can listen at the same time. Simultaneously, you can listen, you can talk, you can listen, you can talk. This means the data is flowing in both directions. Your internet cable is most powerful. Your network routers are more powerful. They can receive and send fraction of data. Why? Because world is connected with fiber optic. Fraction of second your data can reach and send back and forth, something like this. So that's why we can say, if I'm asking, the latest application kind of WhatsApp, FaceTime, Facebook Messenger, they are using full duplex or half duplex. So you need to select which correct answer, something like this will comes in your class test. Yeah. So please try to listen. This will be lots of questions. This is very important. Maybe I will take a little more time. Multiplexing. This is very important. There will be some question. Let me finish, then I will answer your question if you have anything. So we will discuss. Okay, guys. Multiplexing, maybe it's a bit tricky. You don't need to understand. So I'll let you show you something here. So yeah. Let me tell you something, the multiplexing. So let's say you have a mobile phone, any mobile phone. I'm not supporting any brand, so don't worry. Sometimes I'm saying like, the MDPI, sometimes I'd say like BlackBerry. So please make sure this is not just supporting any brand, whatever you are using. You might have seen, the Apple mobile phone, the Pro version. They have different cameras on back. Like, they have 3 cameras on back and they have just 1 cameras on the front side, like, face camera. But again, this is the same mobile. Let's say this is the sensor, macro sensor, micro sensor, zoom sensor, normal sensor, and this is a front like hybrid camera. At least like a latest camera, also latest mobile phone these days they are using nearly four camera sensor, nearly four camera sensor. So these are the cameras, not just like a fake thing, the redundant thing. Again, this is genuine camera, this is genuine sensor, this is genuine sensor. They are working. But do you know your mobile phone, the body is very tiny enough. So they have just very small circuits. Circuits mean the motherboard like this one. There is, let's say this is battery, this is like motherboard, like we can say circuit. Let's say this is circuit. Let's say we have more than four cameras and mobile is very tiny these days, very larger, smaller scale, sorry, smaller scale. Again, they are using four camera. Why? How it's possible? They are using four cameras. This is very small mobile, slim mobile, very thin mobile, thin circuit. So because of why? Because the cameras, they are using multiplexer, a multiplexer for camera circuit. So what does it do? Let's say they are using one multiplexer. So this is connected, one camera, another camera, third camera. If you are opening the first camera, so this is sending signal to this multiplexer. If you are opening a pro version camera from the rear side, all three sensors, they are sending sensor to the same circuit part. Yeah. If we don't have multiplexer, what will happen? Our camera will be bigger than the laptop. So we can't use four camera. Why? Because we need separate circuit for all camera. But because of multiplexer, we are using lots of sensor with just one logical circuit. So that's it. Yeah. We don't have just 1, 2, 3 camera. We have more than microphones as well. They have two microphones here, two microphones, all these things, another multiplexer. The microphones are connected with multiple everything. Once is more than one's quantity. If number is more than once, they are using multiplexer. Multiplexer mean, so let's say there are four cameras, all camera they are sending signal, but mobile is just processing once at a time. So this is multiplexer technique, yeah, and they are sending just as a one output. Yeah, four cameras, one output, three microphone, one output, something like that. That's why it's possible, slim and smaller, something like this. Yeah, that's why our internet is faster. All these things. Let me talk about the multiplexing networking now. Yeah, again, the multiplexing function is the something similar, like your router, your switch. They are again using the same thing, like the circuit for multiplexing and demultiplexer. Let me show you. Let's say we have lots of, let's say we are in the input building classroom. So let's say we are using one wireless access point. We have more than 50 PC, one PC, second PC, third PC, fourth PC, more than 100 or 50 PC. So what they are going to do it's kind of, the combining a multiple signal. One router is combining a multiple signal, lots of signal. Like some say, I need YouTube, I need ULA, I need this Google, I need this thing. All signals they are passing through multiplexer. Then what multiplexer is doing? After converting mathematically, it's sending just one line. The internet is just one. Our UWS campus has one main internet, fiber optic, not two cables, not 100 cable. Like we are 1,000 students, we are not using 1,000 separate cable. Just we are using single internet service provider. ISP, something like this. So what does it mean? So this means the multiple signals, they are passing through the single line with the help of multiplexer. We say multiplexer. A multiplexer is combining, a numerous, either digital or analog. So more likely we are focused on digital. Analog is very old fashioned time, not now, but it's possible to do it. So what we are doing, combining numerous signals into single composite form, so that we can send over a single medium. So this is our single medium, sending like this way. So this is happening in networking, this is happening in communication, this is happening in your most likely, electrical things, this is happening in kind of, electronics thing, this is happening in old physics, modern physics, all these things is possible. So make sure multiplexer works something similar. Even in our networking devices, they are using more advanced level. Yeah. So this is all about the multiplex. Let's say you send 40 requests from here, and multiplex converted in one signal. So once it's reached server, so server, they are going to demultiplex them. Means they are encoded, decoded. They are sending, I need this, I need something. This is working like this. So we are now going to teach all of you technically and how multiplexers are going to convert, like discrete form or polynomial form, all these things, logical form. So we are just going to cover. It's basically just need to know like how cablings are working. Like we are not going to work according like say. So what we are going to cover now, we are just focusing the fundamentals levels of time deviant multiplexing, frequency deviant, and wavelength deviant multiplexing. So they might be a part of your class question as well. So they are using with different multiplexing technique. I'll let you know now. I hope this is clear. If not, then I will give you time. We will discuss later on. Let me finish first. Okay, so first of all, frequency deviance. You might have heard like, frequency. If I'm giving you some example, frequency is very, very common right now, wherever you are every day, even you are in hospital, even you are in the railway station, even you are in airport station, even you are in any restaurant. Make sure the frequencies, like, the different wave signals, they are always coming inside the building, inside the environment, different frequency. Someone's like, 2 hertz, 3 hertz, 5 gigahertz, 10 megahertz, maybe, audio frequency, video frequency, maybe, dish antenna. Everyone is sending signals like, everywhere, something like this. So we say our environment is fully loaded with frequency, the wavelength with waves and electromagnetic wave, but they have different ranges. So make sure if like, the sky satellite, you are using sky satellite, wherever you use it, so you can get signals. So sky has a specific gigahertz, megahertz range. Let's say you are using any like, Starlink internet. So they are going to use, just a minute, someone is, just a minute, guys. Someone is calling me from the university. Please stay there, so I will continue. Yeah, just a no worry. I'm coming outside. Yeah, yeah, I can come in 2 minutes. Sorry. Yeah, sorry, guys. I will be back in 2 minutes. Yeah, so you can stay. But there's some delivery outside, so I'm just trying to. So please stay there. I'll be back soon. Yeah.
Hello. Hey guys, do you have any group to join?
Bro, do not make a group here. Just make a group whenever you went to the university. 2 days or 1 day later.
Wow. Mi novela sangre.
هنكودشة
Derivala Frida. Leccerta partito in pesca.
Like man side panding. O braga le leonismo.
namong nakaltegi baka شو disconnect شو صوبة enter شو
لك قلتك يا بنا قلتك ما ديسكم كاودو. Exception college.
Is beladina vimala. Awala kari shada
देखिए
group.
फिर देखो डेटाबेस क्लास की बगल देखे
database वाले link share करी
دا لينك دي كلاس دا لينك دا ليكشر کې په ولا باندې بلاش کې کسان ته لاوسم لکه دا لينک د اولا کې شیر
के छ हरि ब्रो ब्रदर कता हो हरि ब्रो
यतै हो
फुल्ली म्युट गरिदिएर सेल्फ
Hi guys, sorry for a delay. So it was a delivery outside, so sorry for interference here. Let me finish. Please try to mute everyone. So let me continue. So I think so we covered the multiplexing. Let's talk about the frequency. You know, frequency multiplexing means, so what we are going to do, we are combining a lots of signals like numerous signal in the form of different frequency. Let's say any device or any appliance who is going to send signals with different frequencies. So what they are going to do, they are choosing different frequencies, like, you know, just assume like 1 hertz, 2 hertz, 3 hertz, different. So no one is using 1 hertz. That's if someone is using. So this is rule. Combining signals in the form of frequency, then they are sending in the form of frequency. You know, frequencies are going to be passed through a one medium. We say data is flowing in form of different channels of frequency. And how frequencies they are traveling under ocean, under the sky. So they are using, you know, guard band. The one frequency is covered with kind of, you know, separation. Separation is kind of, you know, logical thing. So one frequency is like 1.2 gigahertz, another is like 1.3 gigahertz. There is some range to, they don't interfere and depletes each other, something like this. Yeah. So this is all about the frequency deviant multiplexing. So single medium in the form of different frequencies. Make sure they are sub-channels. Different frequency means sub-channels. Maybe this is question in your class test. So please be ready. Yeah? So where we are going to use the frequency deviant multiplexer. So frequency deviant multiplexer, they are going to be, you know, transfer. Please, can you turn on your microphone? Otherwise, you know, this is, you know, everybody is trying to be disturbed. I can mute all of you, but this is very bad. You know, I want you to interrupt me later on. So please try to mute you. If you don't want to listen, so you can just, you know, leave as it is. Yeah. So trust me, if you don't listen to me, you might be in trouble later on. You will find it. Those who are not listening, they have a lots of bad success rate, you know. In BDCN, I can tell you, I can show you maybe end of term, 60 students, they got failed. You know why? Because they didn't listen us. Yeah. 60 is one of the biggest number. So I would say please be engaged and listen carefully. Yeah? At least allow others to learn something. Yeah? Thank you guys. So please be very, very active here. Yeah? So this is frequency multiplexing. So they are using, so in especially, you know, untwisted pair, serial cabling, and very, very small to medium level. So you can use something in your coursework, like you can mention anything if you want to very, very accurate and good mark, something like this. Yeah. And second one is like, you know, wavelength based, like, you know, different wavelength. The frequency is different, the wavelength is different. So what does it mean? Again, it's same thing, like, you know, our numerous signals we are going to transfer into a single transmission medium, like, you know, but what form? So we are using different of the wavelengths. Wavelength mean the color of light. So make sure once we say wavelength, so make sure you are only going to use cables with fiber optics, like cable with the glasses, one of the fastest cable. If we use wavelength division, so we are going to cover highest speed network cabling. We are using the longest distance cabling, like, you know, let's say YouTube server is connected with this kind of wavelength division. Google server is connected with these kind of techniques is WDMC. Why? Because, you know, they are using under ocean from Asia to Europe, from UK to Europe, something like this. So what they are going to from America to Europe, they are connected with the fiber optics under ocean. Okay, guys, so they are covered with lots of under ocean cables. So we say signals must be coming across different wavelength. Wavelength means different color. If you use any prism, try to pass any light, so you will find, you know, one light is combination of 7 rainbows, we say color. Maybe you can see during the rain time, you know, a rainbow different colors. So light can pass this into fiber optic. So once we send signals, so we are sending the lights, not electric signal. Lights is passing more than highest speed, like, you know, speed of light, something like, you know, is 2 times 10 raised to 8 meter per second square. Maybe we need to check later on. So please make sure this is one of the fastest, one of the longest distance covering the wavelength. It's all about the time division. This is something very old and fashioned. Like, you know, I said in olden time, we were using, you know, the telephony line. We were using telephone lines to communicate. We were using the telephone lines to use internet, a dial-up modem, which was just below the 1 megabytes. Maybe I think 50 kilobytes per second, maybe 10 kilobytes per second, which is very, very slow, you know. Let's say maximum I have used kilobytes per second, something like this. Yeah. 50 kbs. It's very, very slow. We were using, you know, PSTN, public switch telephone network, to connect from a telephone line to PC, something like this. The time division was a part of this thing, but right now it has been improved. So all PSTN is using is still some copper line, like, you know, local area network category 4, 5. They are again using the copper lines, you know, LAN with category 4 and 5. So time division means that we are sending a signals, multi or numerous signals into the form of different time fraction. Let's say a one PC is a different time, another PC has a different time allocated by multiplexer. So A should go at the third, B should go at the fourth, something like this. So they are sending kind of, you know, fraction of time. So this is all about the time division multiplexing. Yeah. But make sure the application is very important, where we are going to use it, where we are using wavelength, where we are using frequency, where we are using PSTN. So this is gonna be very, very important for all of you. Statistically, is again the same thing, but there is some kind of, you know, the same thing. We use PSTN copper, but this is using kind of this different approach, like, you know, different statistical time as compared to the previous one. Otherwise, this is same thing, same slow. Let's finish the media now. Very simple. So in networking, in digital communication, we have a lots of media right now. We are going to use, you know, different kind of media. So transmission media can be occur with, you know, guided and unguided. Yeah. If we say guided, so this means this is definitive. You need to be, sorry guys, there is one important call coming. Sorry, because, you know, we are dealing lots of program levels things, so I need to respond. So I will be back in 1 minute. Sorry. Yeah. Hi, can you hear me, Daniel? Yeah. Yeah, I'm good. Daniel, sorry, I got
Yes,
just
sir.
call from Alta.
I can't hear you, sir.
Sir is on mute.
Sorry, guys. So I think the guided media is all about like, we are using any fiber optic, like, to communicate the physically connection, or we are using any, the kind of, twisted and untwisted cable. So I would say everybody, this is just listening. So I would say try to learn something from Google. What is UTP and STP? These are the common cables you have used before many times, most of you. So kind of, this is twisted, mean the one each where orange, white of orange is twisted, green, white of green is twisted. Untwisted is cheaper, twisted is a little bit expensive. It's kind of, big, faster, little bit faster. But you need to check all these things, please. The twisted, coaxial, all these things. So this will be really helpful. I would say you need to mention all cablings, pictures, and justification in your coursebook as well. So guided, these mean all the coaxial, whatever you can mention. Unguided mean whenever the communication is happening without a physical cables, like, how aeroplanes, they are communicating with their kind of, towers and destination. They are using GPS, satellite. They are using lots of, communication, unguided communication, microwave, infrared, radio wave, electrowave. They are using lots of, effect kind of, parabolic and hyperbolic antennas. We say that towers are maybe, we say satellite. They are connected. Anything connected with hyperbolic, parabolic, satellite, dish antenna, all these things, they are known as unguided media. So we say a media can be transmitted wirelessly through the air, can be a source, maybe, even simple things. We can't transfer any media under the ocean with wireless thing. Why? Because, water cannot bear all these things. This is only possible with a guided media. If you want to pass anything under the water, under the ocean, only the fiber optic is a possible way. Okay, guys, in the air, we can transfer all these things. Air has like, simply it can accept all these things. That's it. So microwave, radio wave, all these things. We are going, even our, let's say your mobile phone has just not one like modem, so you need to connect internet. There are lots of sensors. They are using GPS, they are using, location proximity sensors, compass sensor, lots of things. They are going to use it. Who is going to connect them? Who is going to provide the data and statistics? Something like that. Even I know the internet is a first hub for the connectivity. Internet is not doing all these things. Your Wi-Fi. If you don't have Wi-Fi, again, there's some sensor from the mobile phone. They are working with unguided media, with wireless communication. They are sensor, their south towers, they are going to connect them. Yeah, maybe, GSM, maybe LTE, maybe VoLTE, something like this. So they are going to connect all these things. So we say media is in two categories, guided and unguided. This is simple. We showed you before a twisted and untwisted. This can be used for smaller. I would say if you are going to work on coursework 2, so please try to use this thing. If you are using category 5, so please try to use category 5. If you want to make faster internet, so you can say category 6 with 1 gigabits, 100 megabits per second. So you need to mention this cable. Especially they can be used for local area network connection. So you can't connect any Paisley campus, Lanarkshire campus with London campus with category 5 and category 6. Even you can't use these guys, like, you can't use with British Naval connector with coaxial cable. This is very simple. Once you are going to use smaller area network, like, one building near to another building, maybe you can connect import building to export building. but should affect as well. But I would say once this distance is longer enough, communication needs lots of, propagation delay. It needs more power of like, upstream and downstream, then would say, oh, you need to use fiber optic. If there is no like this way, so both buildings are very near, maybe you are going to connect everything inside the classroom, I would say use these cables, something like that. Like classroom 1 is near to classroom 2, then you can use serial. If you are using import export, you can use serial cable, but again, this has some range, so you need to think about it. Yeah, guided media, they have a range for the communication. So please, this is just thing. If you want to save some money, connect all the classroom category 5. If you want to make more than powerful internet, so you can use category 6 cable. It's up to you. Depends on the prices, the configuration, whatever you're going to use it. Yeah. Okay, guys, so guided are almost the same thing. And there's one more thing, fiber optics. So we are going, these are just categories. So maybe this is older things. So right now it's been changed. So I would say try to check this later on. The internet communication, their protocol, their specification. This is very, very matters. This is really, really helpful. How many meters and what speed they can cover. So this must be mentioned. So please try to check them with kind of, reputable sources. This is coaxial cable. I believe you have used Sky antenna, Virgin Media, Dish antenna, maybe, anything once you are watching. If I'm asking, the coax cable, and probably you have seen this long enough. I'm not going to ask, so maybe I can go to check here. And it's very simple. I believe 99% of students, they have used this definitely in their life, a coaxial cable. So you are going to connect this for your TV connection, especially in Asia, Africa, India, Pakistan, Europe, more likely even in UK as well. So you are using this cable. There is a one bigger copper line. There is another insulation. There is another, conductor insulation. There is another insulation layer, something like this. Yeah. So this is a cable, this is second cable, 2 conductor, and these are 2 insulation only. And we are using this BNC, British Naval Connectors. This is very, very famous everywhere. To connect your cables, to connect your TV, to connect your some internet possibility as well, like Virgin Media, they are going to use it here. So this is serial cable, we say serial. Why? Because the main communication is going through this one, yeah, serially, 1-to-1 based on the frequencies they are going to pass it. And this has a capability they can use more than longer distance. Even you can go beyond 1 miles or 2 miles, something like this, you can use it. But make sure this is very famous only for once you have a TV broadcasting, like, fire stream media broadcasting. Whenever you are going to watch 4K video, this will be the best option for you. Whenever you are going to communicate 4K possibilities, high bandwidth, so this is the best things to do it here. So we say serial connection, but we can't connect one server to another with this thing, just to update to make. Okay, guys, so I think you got it. And if you want to connect Paisley campus to London campus, I know there is more than 400 miles. So this is Paisley campus, this is London campus. Now you have to be connected with the different internet protocols, like, multiple protocol labeling switches, and they're going to be connected with the fiber optic only. Fiber optic cable. Fiber optic cable, a cable which does carry only the light. There's this fragile signals, If you open any fiber optic cable, fiber optic means a cable which is made with the glass. Glass means which can not transfer any electrical signal, which only passes just signals of wavelength. Different wavelength means the red color. If you open fiber optic, they are sending and receiving signal. They are sending in the red color light. Red color light is kind of, different wavelength frequency. The internet signal, video signal, audio signal, they are passing in the fiber optic. Fiber optic is kind of, glass cables, which is one of the fastest and one of the expensive you can use to communicate with internet service provider. They have range, you can connect not just 500, not just 1000 kilometers, you can connect globally, continents to continent level. But you must use a repeater and booster just in case. So one cable from UK to New York, this cannot support. Definitely you need to use some booster and repeater inside. Okay, guys, so this is fiber optic is made with 100% glass of good quality. Sometimes the crystalline plastic can be used just for the pure copper, for the low quality fiber optic. Maybe you want to use it. It is possible as well, just for LEDs best purposes. Yeah. So fiber optic does work with kind of, let's say maybe I can open just in case. So fiber optic cable, so you might have seen before, you might have not seen before. If you use any fiber optic, they are passing red color light. That's it. This is signal, nothing else. And fiber optic cables comes like this way. If you twist it, it will be breaking. So you can't use it. So please do not twist this down fiber optic cable. They are crystalline glasses. So please, everybody try to mute. Yeah. Okay, this is one thing we done. So in fiber optic, the light passes. Let me show you. Can you check the light is coming? So we can say this is the mode, single mode, multi-mode. Some cable has a big diameter here. Some cable, they have very smaller diameter. It depends like which cable you are going to use it now. So this is multi-mode and single mode. Single mode, which has a very similar pathways, like the inside the fiber optic, the glass has very narrow lines, like we say 5 to 10 micron core, which is just being used for single mode, like very similar bandwidth. So we can send very simple bandwidth. Yeah, bandwidth mean, let's say if we have more than 100 student PCs, so definitely they cannot support it. Why? Because our bandwidth catch-up capability is very lower here. If we have more than 100 PC, we can use, because the gap is bigger here, so we can use 100 PC signals here easily. Why? Because multi-mode is stepping up indexes with different fraction. One light will goes here, it will touch here, it will goes here, it will touch here. So light is making its own direction. It's just hitting and going back, hitting and going back inside the glasses here. So light is passes like this way. If you send the light just hits somewhere, it reflected. Can you see that's a reflection? And all the fiber optic, they have quite like reflection, diffraction inside the cable. So this is good for higher speed and higher bandwidth. Yeah. Bandwidth is something like this. Let's say this is our room and this is our door. If I'm asking all of the 100 students, they can pass one door, 100. No, they can't pass 100 students at once. So you need to 2 students they will pass, another 2 will pass one by one, because we can say the bandwidth is very smaller. Only 2 students they can pass from the door. This means the bandwidth is only for 2 window students. Yeah. If we break all the wall here, so what will happen? So we can say 50 students they can pass at once a time. So this means the bandwidth is kind of capability to pass and go through in and out, something like this. So please make sure this will be a question in class session. I hope you got it, how light is propagated in the core diameter, the multi-core, single core. It depends which cable you are going to use it. Yeah. So this is again, like, the rubrics things for the higher, lower cost and higher networking cable. So you can check. Let me talk about the wireless and we will finish an awesome question. A wireless media, which is very important. We have covered like, wireless fidelity thing. We say a Wi-Fi. A wireless fidelity, which is very common. It just has a one access point. So you need to do access point, try to give this to everyone, dynamically configure, contact more than 100, more than 200 PC, depend. It's a Wi-Fi 6 or Wi-Fi 5, something like this. So Wi-Fi 6 can support more than enough capabilities, more than lots of students. Normally, our entire internet, like once you are coming at home or offices or even at university. So whenever you are coming at routers, they have a wireless local area network access point. So what does it mean? So whenever you are coming, your laptop is going to scan, actively scan. It will scan, the wireless will automatically, dynamically give you some IP addresses to use the wireless internet once you have a accurate credential, something like that. So what does it mean? They are the electrical waves, not a cable, not a frequency. These are just electrical waves with different kind of frequencies, maybe kind of thing. They are passing through ears, So how they are going to work is they have some transmitter and receiver as well. So they are going to send and they are receiving. If your laptop is receiving, your laptop is sending back to router. They are going to communicate with, receiver and transmitter. We say with different frequency range through the access point, they are going to connect it. Yeah. And more likely this is possible inside the local area, not out of the buildings. You can use it inside the building. Out of building, you can't use it. Maybe, 50 meters, 20 meters. If you want to use it, so you need to use the Wi-Fi meshes. This is only possible. If you want to use wireless in your coursework too, you can definitely use it, but make sure you can try to use, Wi-Fi 6 and try to use, Wi-Fi mesh as well. Maybe, the gigabit, any network, you can use it, no problem. You can use, Linksys, you can use Netgear, you can use Cisco, you can use whatever you use, but make sure you can utilize. So you will get good marks. I can say you are interacting well. The other thing is like, wireless media. This is all about the satellite communication. As we say, parabolic, hyperbolic up. So these antenna, they have different, someone is concave, someone is concave and convex and concave. Like, you can see the shape, like inside is hole, outside is like circle. So these are different circles. They are different dishes. So what they are going to do, once this air is full with sensors, they are going to receive. Even once they are sending signal, they are sending from here to into ear, something like this here. There are different form of microwave. We can say high frequencies communication even in the air. More likely our satellite. If I can show you something how our satellite is possible these days, maybe I can say, let's say, our world is like, this spherical thing, like, we are globally connected. How? And do you know, globe has like, this is, let's say, I don't know, this is South Pole and this is North Pole. So we have North here and this is South Pole here. Do you know that even our Earth, there are some longitude and latitudes, all these things. We say our Earth has longitude, latitude, and Earth is revolving in the same rotation into the same direction every time constantly. Why? Because it is maintaining the north and south magnet. So north and south, there is rule. So north and south magnet, they are always trying to interfere with each other. There is communication. Who is going to communicate? If you use satellite, they cannot communicate, but there is a global natural condition, globally magnet from north to south. Whenever Earth is moving, no problem. In the skies, let's say some satellites, they are working here from China, someone working from America, someone working from Europe, some working from, African, Asian countries, all the satellites in our global communication. They are installed everywhere. How they are going to connect it? So each satellite is working with same thing, So north to south, they are connecting. Like Earth is connecting with north and south signal, magnetic signal. They are going to connect with each other. All satellites, they are connected. Not everyone. That's, those who have a complementary connection, they are going to connect with each other. Yeah. So satellites are connected. Anyone in Europe, anyone in Africa, if you're using any GPS, you don't need to pay anything. Satellite, they are sending you signal. The satellite sending this, all the information, this is interdistributed. All these are connected with the help of north and south pole magnet connection. So they are overlapping. Like, one satellite can reach the signals of here, another signal can reach here. So they are overlapping the signals here. Each satellite is under distances here. I hope you got my point. If there's any weather disaster, air disaster, storm disaster, no problem, because again, the satellites are interconnected. They will not affect them. Sometimes it's affecting, but sometimes not, because, there are multiple satellites. They are working together. Earth has kind of these, orbitals things, so they are going to connect. So this is far away, at least, so they can reach with each other. So if this is not reachable, they are using a third satellite, so they can connect with each other, something like this. They are revolving around the sky. In the air, they are satellites. They are working like this way. On the ground, our countries, our native hosts, these are the receiver. They are going to receive all information from it. These guys are sending to them. These are guys receiving from them, something like this. So these are interconnected. So we are using, frequency modulation, FM. We are using, amplitude modulation. We are using lots of watts of microwaves. Weather forecasting. BBC is like using all these things. You can use all the satellites. I hope you got these are special form of microwave communication. Why? Because the propagation delay is very, very long distance. That's why it's very low. That's why it's going to connect with the overlapping signals. That's it. I hope we are not going to ask you to do, but definitely you don't need to mention it. If you want to show anything, this will be possible in coursework, but I would say this is not part of coursework here. I hope this is all done for the satellite communication for media thing. So this depends, like, which factor you are going to consider as a manager. If you are designing a network, you are not designer, you are not developer, but you are running a businesses as well. In terms of businesses, you need to think about the cost, how much internet topology, internet connection, physical cabling you really want to be implemented. So you need to know which network type you want to be connected, and what is your budget overall. So which security you're going to do, and what is error rate. All these things you need to think about the installment. Once you deploy anything, you need to think these things, and you need to be very careful. Cost things, security things, capability things, and improvement things. So then you can deploy which cable is suitable for all of you. Again, so I'm not going to teach you deep mathematical things, discrete thing, binary things, maybe Fourier thing. maybe all these things. So we are just going to show you some information that is you need to know. The digital and analog data. What are the digital and what are the analog data? A digital means a kind of discrete binary value. Discrete means ones and zero. So normally our digital signals, they are going to work with ones or zero, zero or one. This is only logic they are going to use it. I will show you why and how. An analog signal, let's say a communication is possible with the analog signal as well, which is form of only continuous waves. Yeah. If I'm asking, let's say I'm speaking in front of microphone, my voice, let's say this is my voice. So I'm speaking anything. Let's say this is my voice. I'm speaking. So in front of microphone, let's say this is microphone like this way. So what does it mean? The signal from my mouth up to here, we say this is continuous signal. So my voice is form of analog signal. Why? Anything coming from that tongue is a continuous signal, or anything coming from your speaker. Whenever signal is coming from a speaker, this is an analog signal. So audio from a speaker is analog. Audio from your mouth is again an analog signal. Why? Because it's a continuous signal. But once it's going to transmit into cables, into internet connection, this is going to happen only on binaries like this way. 0, 0, 0. Let's say I say apple, A for apple. How it will transfer? A will convert it in discrete form, maybe 0, 0, 0, 1 like this way. A has to be converted in this way. Let me show you. I hope so. Let's say if I say A, so A will be converted in this binary code 0, 1, 0, 0, 0, 0 and the 1. Then it will transfer from the internet and from the router, from the switch. Let me show you what does really means, like, maybe some of you don't know. Our internet, sorry, let's forget about internet. This is our mobile phone, our laptop. Let's say whenever you are pressing A from the keyboard, what will happen? So A is going to convert into the signal, like let's say assume this is 0, 0, 0, 1 binary discrete 1 and 0. What we are getting here, 1 and 0. So you might have noticed, like, your mobile phone, let's say your mobile phone has battery inside mobile phone. So battery is just, plus and minus 5 voltage. If it says 0, 0 mean minus 5. If it say 5, 1, sorry, if it should be 0. If it say 1, 1 mean positive 5. So what will happen? 1, 0, 0, 0, 1 means, so they are just transmitting this voltage, not the signal. If it's going 1, so we assume this is plus 5. If it's 0, 0, we say minus 5, minus 5, minus 5. This means your battery is using power to use inside the logical circuit. So it means if your battery is 5 volts, it's using plus 5, minus 5. If you are using a laptop, maybe your laptop is based on 19 volts, maybe 12 volts. It depends. So if it's 0, 0 will go to minus 12. If it's 1, so it will go plus 12, something like this. So your circuit works with the voltage, not with the logic. The logical board will consume like, minus 12 is 0, plus 12 is 0. So they are converting like this. So all the digital communication things like, laptop, the router, the switch, they are using kind of these signals like, ones and zero. Ones mean positive voltage, negative, 0 means negative voltage, and whatever supply we are going to produce, they are using the same as it is here. One question, if I'm asking, just in case, anybody, you have used your power supply of desktop machine, tower desktop. So at the back of the machine, you have a power supply. Let me show you first. And I will take some break, then I will some, PSU. Tower power supply unit. Let me show you this thing. Anybody, can you let me know? I hope so you are not muted. Just in case.
Yes, sir. Yes, sir.
Okay, so you have used it. Any power supply, I'm not asking from Dell HP, it's almost the same. There is no difference at all. Okay, so this power supply, they have 18 connections, someone has 20 connections, someone has 24 connections of physical connection. So you are going to connect this physical motherboard, your tower board, something like this here. And have you checked this power supply before with the voltage? Anybody have checked the voltage of this power supply? If you have checked, can I ask, so what was the voltage? Did you check this before? Sometimes you are using this cables to graphical unit. Sometimes you are using this port to your, RAID driver. You are using bigger one to motherboard, smaller one to red
So
driver.
they
Are
are different, sometimes 12 volt or 18.5 something.
Yeah, perfect. If you check your motherboard power supply, the maximum range is plus 12 minus 5, but there are some cables like yellow, orange, green, something different. They are using plus 5, minus 5, 3.3, 2.2, something like they are using it. Why? Because motherboard has lots of parts, so they are using some parts they are using 2 volts, some parts they are using 12 volts, some parts they are.
Sir, you have muted yourself.
No, sir, you are on mute, sir.
Sir, you are muted, please.
Sir, we can't hear you, sir.
Excuse me, sir.
वेट
You
करो
are
सर लॉगिन करके वो माइक अनम्यूट करेंगे वेट करो
Sir is trying, guys.
okay. Then
Thank you, guys. Sorry, I was logged out from of authenticator.
sir, we cannot
Sorry,
listen.
thank you so much. Yeah, so I know it was a problem. Sorry, guys. So let me continue. Yeah, so I hope so. Please let me finish. So all the circuits, they are using different voltages, positive and negative, but make sure they are not going to exceed more than 22, something like this. Even router, even digital communication, 20 is maximum voltage. Okay, guys, so they are using different communication ranges like this one. So discrete is all about, ones and zero, but we are assuming one mean positive, zero mean negative things. So this is all about the discrete things, continuous binary values. So we are not, anyone, can you let me know, do you want class questions, something from discrete mathematics, or do you want free from the discrete mathematics? So I know there are lots of students, they cannot answer this very well. So I would say we don't include them, something will be better. Yeah. So I will not include any something because I know if I add something like digital things, so I hope so this might be difficult for you. Time is very limited there. The class test is again online, so this will be difficult for me to manage as well. So I would say there will not be any question regarding ones and zero with binary calculation. So you don't need to worry for all these things. Okay, guys. Please check some calculation at least, ASCII characters, Unicode characters, hexadecimal character. So how they are going to encode the schemes, different. How is going to be in decimal, how is going to be in binary. It's super simple if you can use online calculators. But make sure our digital communication, our computers, our mobile phone, they are going to use this thing inside the network, inside the cable. Whatever we discuss, this is only communication. They are going to use it ones and zero. That's it. Yeah. Our logical circuits, our router, your mobile phone, they don't know what is A, what is G. They just know ones and zero. And ones and zero means they are just voltages as we discussed, plus and minus, that's it. Digital transmission parallel means the parallel communications going through in this form. That's it. The bits are multiple form. Guys, if you can mute yourself, please. Yeah. I don't know. Okay, that's muted. Mohsen, you are unmuted. Please try to mute yourself. So student, they are working somewhere. They are joining the class. I don't know, Mike. Please speak. Hussein, you are.
सारे
म्यूट करने को मैं
respected sir, you are allowed.
Sorry, yeah. Thank you. Yeah. So please be careful. Yeah. So parallel means all the things they are going to be transmitted parallelly, you know, and serial means everything is going to be transferred sequentially once at a time. So if I can ask you any question in class 10, might be you have used the USB universal serial bus 1.1, 2.0, 3.0 or 3.1. This is type of, you know, anything like you are using serial bus. So this is your serial, but they have 4 connections inside, you know, data, voltage. So things like this, so we say USB port, something you are using your flash drive, memory core. They are the part of, you know, serial things. So transmitting to sequentially at a time, like one line is to be used sequentially, but this is super fast right now. So you can check this issue. So this is the same thing we say that any positive thing is encoded 1, any negative thing is encoded 0. So if you're going to check the hertz rate, the frequency rate, so please try to use some formulas. Internet is very famous, all these things. So I will not ask anything, something like this, just you need to know how they are. Let me finish very important thing. Let's say there are different transmission of digital data. If we say unipolar mean if you can check the voltage must be either 0 or positive, but no negative. Now you can check the voltage is like, you know, any signal which is going to pass from 0 to 1, 0 to 1, 0 to 1, but there is no any negative thing. No negative mean which this is a unipolar. If I'm asking same question, so you need to use this thing unipolar, which it does not use negative frequency. Yeah. So let's finish quickly. It's not important, I know. So nobody will learn it, but it's very difficult. Bipolar non-return to 0. If I say bipolar mean voltage is either positive or negative. Bipolar. That's why I say the voltage must be positive or negative. If I'm saying which one of the following is using the positive and negative voltage, like unipolar or bipolar, so you need to select bipolar NRZ because this is the things they are using it. Bipolar non-return to 0. Voltage can be positive or negative. Can you see the signals is positive, negative, positive, negative, negative, positive, but they are not going to go to 0 line. The 0 line they are not using, so we say non-return to 0. Yeah, there are signals they are using in communication, different things.
Sir,
That's
can I
it.
ask something?
Yes, please.
What happens if bipolar gets 0?
What happened in bipolar?
Yes, gets 0. It's not even positive or negative. It
With this
doesn't get
one.
signal.
So you are asking this one, no? Are you
Yeah.
asking?
Yes. Yes.
This is unipolar. Like unipolar mean only one voltage pulse is being used. Yeah.
Okay.
Let's say any signal. Let's say your device is unipolar. Only unipolar mean. So they are either using only. Can you check this line is only upside? Like, you know, signal is positive, signal is positive, signal is positive. So they are using just positive. They are not going to negative things. Unipolar. But this is not the case. So you can use like, you know, there is negative. So you can use like this as well. In negative, but they are not going to go positive. Either they not go to negative, they not go to positive. So we say this is unipolar. Yeah. They are just representation. There's discrete mathematics. They are going to happen inside your logical circuit. Maybe some circuits, maybe, you know, local area, maybe media access control, maybe multiplexing circuit. They are going to use different patterns of digital things. And you know, all the patterns are not common. Let's say, have you seen your motherboard before? Yeah. Just in case, let me show you, you know. Let's say I'm just writing Dell motherboard, just simple things so at least we can cover. Let's say this is Dell motherboard, you know, there's just motherboard, we say logical circuit for your computer, for your laptop, for your desktop. If we can assume like, you know, there are tons of the circuit. This is not just one circuit. There are lots of circuits. One circuit is for internet. There are some parts for internet, some parts of microphone, some parts of power management, some parts of, you know, arithmetical logical unit, some parts for calculation, and some parts like, you know, complementary metallic oxide semiconductor. This is CMOS battery. And some parts for live calendar. If you can check why your PC is almost active with calendar, this is the cell which provide, you know, the mandatory information. The BIOS information is saved with this thing. We are not powering up, but wow, our time is up every time, but we are not powering up our machine maybe after 1 year. Remove your battery, your power will be same, your data will be same. Why? Because the circuits are maintaining these things. So this is giving some power to some circuit, they are using something. There is some kind of, this is our basic input output circuit. There are lots of things. This is our peripheral devices, RAM devices, a lot of circuits. So that's why, this device is using different approaches. Maybe they are using unipolar, maybe someone is using bipolar, maybe non-return to zero. They are using different patterns of communication. That's why, it's possible. If they use the same pattern, bipolar everywhere, maybe, they will disrupt each other. That's why, communication is possible with different patterns of approaches. Maybe they are using different signal. One is using this, someone is using this, something like this here. So there's is just thing, bipolar. It's just simply you need to know unipolar mean only one voltage is being used, but there should not be any negative. That's it. So even they can use positive, but no positive. One they can use negative, no positive. This can be possible as well. Okay, guys. So bipolar NRZ, bipolar non-return to zero means so you don't need to return zero. If you are asking bipolar return to zero, this is possible as well. Bipolar mean they can use positive, negative, but they can must use. If your question was like this, so you need to go here, then you need to go upward. This is possible as well. This is pattern as well. Bipolar NRZ, bipolar return to zero as well. So this is another approach. If you are asking bipolar return to zero bipolar means so we should have both poles. Both poles mean positive voltage. Can you check positive is covered, negative is covered, but this say return to zero. Now, can you check the signal is returning to zero? That's it. Yeah. Bipolar both poles and make sure this is going to return to zero. Signals can go. There are different patterns. Why? Because we need to synchronize them. We try to remove like, anonymous error, something like this. So we are using in different communication. This is technique common for all circuits. Even you are using iPhone, even you are Android, even you are BlackBerry mobile phone, everything is same for circuits. If they are using the same multiplexer, same let's say if you are using Sony cameras inside iPhone, inside Samsung, they will use the same pattern for these things. This is common for all devices. Yeah. Okay, guys. So make sure Manchester in. Yes, please.
So I do have a question. Do these different types of, signaling techniques also determine the strength of the signals, or these are just, representations?
Can you repeat it? Sorry, your voice is okay, but there was some, I didn't hear you well. Sorry. Repeat it again, please. What did you say?
Okay, so we've been studying different types of signaling techniques. My question is, do these, different types of signaling techniques also determine the strength of the signals, or these are just, representations?
Yeah, exactly. This is good question. These are presentation of signal, and this is a unique for all the devices. As I said, if you are using, let's say you are using Apple mobile phone, just we are taking an example. Someone is using, Samsung Note mobile phone, something like this. Yeah. Maybe you don't know, like, the Apple is using the Sony camera sensor. Maybe Samsung is again using Sony camera sensor. So what they are going to use, so they are using the same pattern of signals for cameras encoding, decoding. They are using same coding of signals encoding, decoding. Yeah. More like, the camera is not made by iPhone, camera is not made by Samsung. They are the third party. They are going to use it. Yeah. Maybe inside your iPhone, inside Samsung, there is different multiplexer chip here. Like they are using same multiplexer chip. Nobody knows it. Depends, like, maybe Huawei is using same thing, Samsung is using same thing. If they are using same thing, so their pattern will be the same with each other. They are working with same pattern, definitely. Their strength is same, their pattern is same, their encoding, decoding pattern must be same. There is no changes. Definitely, this is unique pattern. We say standard from the global perspectives here. So that's why they are using different encoding, decoding. And make sure if you are using Dell motherboard, if you are using HP motherboard, make sure their techniques of working must be same. They have to follow, American ASCII. Did you see the ASCII, American Standard Character Interchange, information interchange? Yeah. So they are using the same character. This is same for all manufacturers. Even they are Dell, even they are HP. They must follow the same standard. Yeah. They need to follow, ISO standard organizations as well. They need to follow, CE standard as well. You can check all marks. Once you buy a laptop, they are say we are certified, we are certified. So they mean they are following, checking all the standard. Yeah. If they are not certified,
So
maybe they
these
are
are just
using false.
representations,
Yes.
right?
Yes. Sorry.
So
Yeah,
these
this
are
is
just
common.
representations, right?
Exactly. These are standards. Yeah.
Yeah, thank you, sir.
No problem. Thank you. It's a good question. Yeah. Analog transmission
I
of
have a
digital.
question, sir.
Yes, please.
Sir, how does Manchester encoding ensure synchronization without requiring a separate clock signal?
Manchester encoder is just like, voltage transition instead of voltage. Like, transition mean they can change like, different voltage. As I say, power supply, we said before. Did you see the 24-pin power supply? There are different patterns of voltage there. Yeah. So sometimes they have a specific voltage, just use 5 minus or plus 5, or by Manchester, they are going to transit them. Transit mean different voltage. They are using different patterns. Depends which circuit. Even I'm not sure like which Manchester is coding, which circuit they are going to use. We need to check this in detail from the Google's thing. Yeah. So they are using just transition, voltage is positive or negative, but they are going to be changed slowly once they are using in different approaches. Yeah. There is nothing like we haven't checked, so I didn't provide anything, but we can see this later on. If you need to show me, we can discuss. Don't worry. Maybe we can discuss at campus, please. Yeah. Even I have to search. Definitely, I
Thank you,
didn't
sir.
check.
Okay.
No problem. Let me finish this very simple analog transmission. Analog transmission, I think we need to go very simple with that. Analog transmission mean the system built for analog data, something like, analog mean the continuous signal. If I say electrical signals, let's say, okay, how analog signals they are going to work, let's say. So, analog signal always they work with, modulator and demodulator. Let's say this is modulator. Let's say this is demodulator. We are saying this is demodulator and this is modulator. So let's say I am sending, say, hello words here. From my voice, I say hello. This is sinusoidal wave, like, continuous signal. Like, crest, trough, like this. This is continuous signal. Discrete is always like this and this. Okay, guys, so this is continuous mean which has sinusoidal waves. Yeah. I say hello. So what will happen? Then microphone will convert my audio with a modulator. Audio will be converted in discrete, like discrete. Then it should go like this discrete. Then it will go to demodulator. What does it do? Demodulator will convert the signal with the help of, did you see the speaker, your aux output speaker? So demodulator will work with the speaker, then it will say hello, what, then you can listen my voice. Yeah. Modulator is converting with the microphone a continuous signal, analog signal into digital signal, then digital signal with the help of demodulator or speaker, they are going to be converted again into the same voice, my voice. So this is my voice, this is my voice. But during the communication from here to Paisley, from here to Asia, it was just digital signal, something like that. So that's why we say we need a modulator, demodulator as a circuit, which converts analog to digital voice and versa. So this is why you have seen the microphone, your laptop has it, your mobile phone have it. You have a speaker in mobile phone, laptops, all these things. That's why, they have using modulator, demodulators, converting all these things. Yeah. And this is just form of, the analog signals. Yeah. Continuous signal mean they have some phase. Phase mean this has some angle. If you can check 45, 30. Amplitude mean how long it's from zero level to top level. So, crest and troughs. Yeah. So you need to measure this range. This is amplitude. This is phase level, amplitude level. From start to end. So we say this is a wavelength overall of the signal. Yeah. So this is just, physical attributes. So you need to measure. We are not covering here. This is just information for you. Yeah. If this is bit higher, we say wavelength is higher. If it's bit low, we say wavelength is lower and faster. If we increase this thing from here to here, means the signal is very low. If we increase like this, so signal is fast. Why? If wavelength is reduced, the frequency will be increased. Depends on the calculation, hertz and degrees level. And even this affects as well. So there's calculation I'm not going to teach, but you can do. What is amplitude? So this is amplitude. What is hertz? What is wavelength? All these things. So this is the thing we are covering in analog signals. But very important things, so let me clear all this thing. Yeah. Anybody have you used, anything like, FM 101? Have you used this before? Once the memory card was not famous. Anybody you have used FM 101 or any FM, not asking 101.99 FM.
Yes, sir.
108. So you were using free charge of song. Just charge your mobile phone or buy just, £2 FM frequency modulation device. Take this out and scan the code, just fix the frequency 101 megahertz. So you are going to listen your the local repository of sounds from the station. FM 101, FM 99. This is very simple. Why? If we talk about the frequency modulation, this means, so this is your house and FM station is near to your house. Maybe, if someone is London, so London has lots of FM station. If someone is from Mumbai, India, Karachi, Africa, Europe, so what this happen inside their houses, near to house, there are lots of FM station. They are going to send and receive signals here. So station they are sending within a range, maybe, maybe 20 kilometers, 5 kilometers. This is the range for frequency modulation. You can listen quickly. But let me ask, let's say if you are driving a far away from Scotland, you are on the northern areas, Isle of Skye somewhere, maybe northern area of Europe. So you are more than 500 kilometers away from the city. There is no any like signals of human being, something like this. But again, you can listen, the audio thing like BBC, something broadcasting. So who is going to provide you? Only the amplitude modulation. So we say AM, like, your cars, they are equipped with amplitude modulation. You can get the signals more than 400 kilometers, like BBC is broadcasted version. So you can hear BBC more than 500 kilometers with the help of amplitude modulation. If you are away 500 kilometers from a station. If you are away more than 50 kilometers away from FM station, then you can't hear. FM is low range, if AM is a long range distance, something like this they are using, So these are low range, these are a high range amplitude. AM, FM is low range, something like this. Maybe I will create a one question for you, just simple way. Who is the longer range covering things? That's it. This is amplitude modulation means, so you are just changing the amplitude. Frequency means you are changing the frequency. That's it. Maybe this is 101, this is 109 frequency, this is like your 99 megahertz, this is 107, they are the frequency changes here. And phase means the phase is changing. If you can change every time the phase is changing, the angle of the direction is changes every time. So we are not going to teach physical things, all these things, modern physics, classical physics. This is just a representation, so you need to know. And this is binary representation. 1 bit of information is equals to 2 symbols. If you had n bits, so you say 2 power n, yeah. Now you need to convert with the old conversion binary. So I think you need to do with the Google thing. It should be very easier. Analog transmission, this is the same thing we say. So let's finish this analog data rate. This is just formula. If you can check, symbol rate is like this symbols per second. And what will be the data rate? So you need to say which time which say. So you need to multiply per second times 4 bits per symbol. So you are getting 60,000 bits per second. We say 64 kilobits, which is very, very low. So this is the way you need to. We are not asking any question in class test, so you don't need to worry about calculations. Okay. Coding, decoding, they are same thing we say, the signals are going to, pulse code modulation. So this is PCM. What does it say? Let's say this is pulse code modulation. So first of all, it will start the analog signal samples at regular intervals. That's a signal. They are very. Umar Rafiq Khan not listing anything. Please be careful. Quantization, sampling, measuring amplitude. So normally, pulse code modulation is a technique which is converting analog to digital, but before converting, it is going to check sample, signals may be more than 1,000, but it's going to check which sample is going to use it. Yeah. If its signal is under the range for the PCM, it will take sample and then it will measure the amplitude. Then it will quantize them, according to the, amplitudes calculation. So this is the way PCM is working here. There is some logic and mathematics, so we need to show something, but this is not covered in our topic. So I'm just saying PCM is just trying to remove errors, converting analog to digital with the help of quantization. That's it. Yeah. Sampling means, let's say we have one signal from the human audio, one signal is from the dog audio, another signal is from car audio, and another signal is from maybe, the environment audio. Thousands of signals are disturbing. Maybe someone is from air. So PCM is not taking all of them. The PCM pulse code modulation, what does it do? It will take the sample. So we say the PCM should work only for human things. So what it will do? Actually, it will receive the signal from human audio. It will reject all these things. Not all the human, though, like this is near to human and this human is also far away from PCM. So it will reject this. So they will just be designed to check sampling. Sampling means we say take the signal from human, take the signal which is near to you. That's it. Yeah. So it will not take any human away from surrounding. It has taken the sample, so it's easy. got sample, measure them, calculate them, quantize them, then it's going to transfer. That's why, our microphones are designed based on BCMs. Maybe, our active noise cancellation microphone, headphone, they are working based on these things. Yeah. This is just, transmission calculation. So we need to know. I hope so. Let's say this is a, let's say you are like, sender, you say hello with the analog signal. Your audio is going to be happening analog. So microphone is converted in codec form. Now modulator will convert in discrete form like this. It will be sent to here and decoded. Now it will be decoded here. What will happen? Receiver. So here your speaker will convert this digital into again audio signal. Handover will be reached here. That's it. So amplitude modulation again work as well the same way, inside the card audio, that's it. This is way our telephone is working, our communication is working, and this is where our digital things are working, how the physically cablings and connections they are connected with each other. Audio thing, video thing, internet things, this is all about the physical layer. We just covered it, just fundamental, not in details here. Overall, if you are going to be having a manager or director of any industries in future, so you don't need to worry, you need to think which network you are going to design. Your developer will do it, but you need to let them know your cost and budget, your capability of audio, video, and streaming up, streaming down, streaming, what will be capability of access point. All these things, which cable you can go and buy, something like that. So this is a way we need to do. I hope so this all clears for now. If you have any question, you can ask me, or if you wish, you can leave as it. There's no problem. So almost we are done now. This is all from my side. So I hope so. Please try to listen it. And if you didn't listen, just go through the slides. Everything will be clear. I can help you again. Don't worry. Probably, I don't know why the audio is. I'm recording all session, but it's not coming. I don't know. I hope so. You will get this name. Otherwise, let me know. Let me take your attendance. So we are getting numbers. Then you can ask any question. If you wish to leave, you can leave. No problem at all. All done from my side. Any questions? So before moving.
Thank you, sir.
So
Have
can
a
you
nice
please
day.
go back
Thank you
to
so much.
previous so can you please go back to previous slide where there were different types of optical cables.
Which slide? Sorry.
I'm not quite sure about the slide number, but optical cables. Previous one.
Optical. Okay, optical cables. Yeah, optical cable is one of the very, very important things. So you have to be very, very careful. Single mode, multi-mode.
So yes, what is the difference between step index and grid index?
Sorry, which index? Can you repeat it? Maybe your voice is coming far away.
Within the multi-mode, what is the difference between step index and graded index?
Stepping index and coding index.
Graded index, as represented in the photographs.
Oh yeah, sorry, yeah, I can see. Sorry, let me delete first. Wrong. Okay, now this is fine, no problem. Graded and step index. Yeah, this is good question. As I said, before, like, the fiber optic cable. So let me show you. Do you know the fiber optic cables? Let me show you first. So let's say if you are using any fiber optical cable, or we say optical cable or fiber optic cable, let's say. So let's say this is your fiber cables. Sometime, fiber cables. Okay, let me open which has color. Okay, let's say this thing. Yeah. A fiber optic, can you check this thing? Like, can you see the light is coming from the cable? So in fiber optic cable, we have just one fiber cable, fiber of glass. Glass mean, do you know glass mean that? A transparent material, like, glass is the same glass which you are using everywhere. Glass mean very, very fragile, crystal clear like water. Whatever you insert, so it will transfer. Only the light, glass can transfer the lights. No electrical signal, no mechanical signal, no magnetic signal. So light is going from here. Let's say if you have a cable and you are connecting from London to Paisley campus, same cable can pass same not electrical signal, light signal, fraction of second. Just send it, they will receive it at Paisley campus, quickest enough. So this is a fiber optic cable. So let me show why it's happening. And if you check that, the diameter of light is something smaller, sometime very higher. Yeah. Some cable has very simple here, something has very, very bigger one. Yeah, let me show and cover it now. So let's say if cable has like, bigger enough, let's say this is fiber cable. Okay, let me show you. This is fiber cable and this is fiber cable, different fiber cable. Like, let's talk about the graded and step index here. So fiber optic mean this is glass cable. Let's say you insert any light here. So if it's a step index means the inside glass is designed like this way. So when the signal will transfer here, it will bounce like, different angles like this, 45, 45, 35, like this. Step index means there is gratings, like, once the light is touching on this surface, it will be go different direction. Why? Because the light needs a path to transfer, otherwise light cannot transfer here. So that's why the light is designed in the surface, like it will touch here, it will be diffracted the same direction. So if you can check here, this is maybe 145 degree, same signal will use the same degree 145 every time. Why? Because the surface is designed in this way. Once it's touched with 145, it will reach entire journey with 145 diffraction index. So we said it's a step index, because the surface is designed to diffract with a kind of angular thing. If we design this glass like this way, let's say we are sending signal like, a multi-mode graded index. So we say our signals is going to be moved like, it's this form and this form. Once it's reached, so it will be transferred like this form and this form, like this way. So these are just surfaces, they are going to allow the signals passing. Otherwise, there's no difference at all. So they are sometimes cheaper, they are expensive, they are fast enough, they can be used for long distance, they can be used like 100 miles, something like that. This is different techniques, Otherwise, there's no difference. Single mode is always a straight line, very, very cheaper. That's it. Yeah, you can use far more than 100 kilometers or 200. That's it. So this is just technology. You can use step or you can use gradient. That's it. Okay, so I hope so you got it.
Yes, sir. Yes, sir. So these are just how they are designed, right?
They are how they are designed. Cable surface is designed like this way, and the sender of signal, they are used to be transferred in this way. That's it. Yeah. And they are just making the signals to pass from London to Paisley, something like this. They are different rays.
I do have another question, sir.
Yes, please.
So it's just a situational question. If budget wasn't a problem, is it a wise decision to use fiber optics to connect import building and export building, for example, because they're too close? And if what would you suggest? What is the best medium to connect?
Yeah, let's say
Places.
this is again good question. If you want to connect fiber optics, definitely you can connect, but you have to pay a lot of money. Fiber optic, you need to pay a lot of money. So you need a transducer, repeater, all these things. They must be. If you are using in coursework 2 fiber optic to connect, import and export, definitely you can use only for core layer and internet service provider, not for internal connection. You can use, but you need to mention how much cost you are going to pay. That's it. Yeah. But you can work with the same, serial cable as well. But serial cable is very, very poor in connection in upstream and downstream. Both are possible. Yeah, you can use it. Only
So what
cost
is the
matters.
So we're just seeking your opinion. So what is the most optimum cable that we can use based on cost, transmissions, and considering all the other factors? What would you suggest?
I would say if you are going to design network, let's say import building is very, very gigantic building and export is very gigantic. There are lots of floors. Let's say we have more than 1,000 students here, more than 1,000 students here. So I would assume connecting these core services like core router must be connected with fiber optic like this. Because if a student number is increased, so we can support with highest speed. If we use coaxials, this will be very, very super internet, very slow internet, so we can't assume it. Yeah, fiber optic will be the best solution because of internet capabilities. Definitely yes, and you can use no
Thank you,
problem
sir.
in your coursework too. Yeah, because I know this distance is very limited, but you can see our capable students are more than 1,000, more than 1,500. So definitely we need a high speed internet here. Okay, guys, so I hope so. I have to be, I think right now we don't have any
Are we
tutorial.
going to do virtualization in coming tutorial?
Hopefully we will do here. I will not teach all of you, but my our lecturer will support you at campuses. But don't worry, I will be at campus Friday. Any one of you can meet me. We can discuss whenever you have any problem. Don't worry. Yeah? And make sure and you need to start working on the verbal presentation. Verbal presentation is an individual submission. I will create a link very soon, and make sure verbal presentation is a recorded version of MPV4 file. What you need to do, I would say everybody, you need to read all the frequently asked questions and feedback right from there. Everything is there, what you need to do, what not to do. So all things are there. Yeah, we have covered. So let me take some break. I have to start another lecture because continuously I have to work. And if you have any question, don't worry, in coming session, we will discuss. Before this deadline is coming here, I will run completely how to do what to do in verbal presentation, but make sure you need to start working on verbal presentation right now and check the frequently asked question, FAQs and feedback. This is very, very important. Everybody need to read it carefully. Yeah. Read it carefully, watch this carefully, all information you will get from here. Yeah. Okay, guys, and there are lots of samples I have uploaded for you, just in case you need to know. And please make sure there is no title for verbal. Make sure you need to make verbal presentation ethically from the coursework too. And the verbal presentation is individual for all of you. If you didn't submit verbal, so you will lose this module. So you will fail and you will be reseated again. Okay, guys. So please, your success is our success. Yes,
Hello,
carry on.
yeah, sir. So, I have no academic questions, so I was just questioning regarding the attendance as me or some of my classmates, we have just joined on 9:03 a.m. 2 or 3 minutes late, and as I was stuck in train, so I didn't hear you properly. So I was just
Yeah.
thinking and asking about the attendance. If
No, it will not affect you. If you have joined any time, make sure you are more than you join 1 hours, that's it. So we have taken more than 3 times, that's it. You don't need to worry.
okay, sir. So our profile, you will count on our
Yeah.
profile. Yeah. Okay. Thank
Yeah,
you, sir.
because that's why I'm randomly checking. I know because in some students they come 5 minutes late.
Hello, sir. I have a question.
Yes, please.
Excuse me, sir. I have a
So,
question.
is there any
Excuse me,
topic
sir.
for us presentation, or you give the topic?
No presentation topic. If you use presentation topic, someone will fail you definitely. So please read this frequently asked question I said you.
Okay.
Everything is there. If you want anything regarding material specification, question answer, so please read, everything is there. I have discussed 2 weeks before, and everything I have clearly mentioned and recorded in the text as well. If you make any topic, so somebody will fail you, please.
Uh, Excuse me, sir.
Presentation based on coursework. Sorry, what is question next?
Sir, I have one question that
Physical
we have.
class on Friday.
Physical, yeah. So I will be there. So someone must be on campus. Maybe different day. Maybe someone on different day. Someone on Friday. So you need to check with Salket. Yeah.
Sir, I have one question over here.
Yes, please.
Sir, we have another lecture starting from 11 a.m. So it will be on the same link or the different link will be shared?
No, this is for my lecture only. I will not run another lecture. Someone will run another lecture. They will use different link, definitely. Yeah.
Yeah, but we have not received in Aula. The link is not received in Aula. So how we can get the link? Because lecture will be started on 11 a.m.
So did you check email from Volkan? The first week Volkan shared you the information. This is link for this class. This is link for this class. I'm sending every week, but some lecture they are not sending every week. So you need to find from email. Find it from Ula. Some pages definitely must be there. Yeah. Our emails
Okay,
to
sir.
your
It is
lecturer.
not.
Please.
It is not in Aula. Okay, I will check it in email.
Please use you just check Volkan Tonali. He shared with you maybe. Otherwise emails to Volkan. Volkan will share with you quickly. Don't worry. Yeah. All lectures links, so he will share with you. Please don't miss. This is very important. Yeah.
Excuse me, sir.
Yes, please.
Sir, do you take our tutorial class or someone else is going to take?
No, right now we are not taking online. Someone will take on campus now. We have started on campuses. Check calendar and join on campus accordingly, like you are scheduled, please.
So, if I join in the morning for 2 weeks, can I do that?
So I think this will be asked from Volkan is your program leader. So please contact with him. Yeah, he's going to manage.
Okay,
Good morning, sir.
Good morning, please. Yeah.
Do we need to complete the lab 1 work?
If you can, that will be helpful. You are just practicing. If you're not going to do it, so means you're not interacting really. I would say practice it and show your things to your lecturer on campuses. That will be really helpful. We are practicing you just in case you need to learn and you need to get some good marks. Yeah. Those who
Is
are
it like
practicing, they will good mark. They will get good marks, definitely.
okay, is it like a group assignment or just we need to do it individually?
If you have group, do it in group. If not, then you can submit alone as well. But make sure for coursework to submission, you must have group members from
okay.
1 to 5 members. If you cannot find it, you can submit alone as well.
Oh, okay. Thank you.
Okay, no problem. Yeah. Okay, guys, if you want to leave, so you can leave. So I have almost all done. So if you have any question, you can ask any question.
Excuse me,
Yes,
sir. I do have a question.
Please.
yes, please.
Actually, sir, I have a class on Thursday. Are you coming on Thursday on university on Thursday?
Thursday, right now, maybe I'm not coming later on. If you ask me, I can come sometime. But normally I'm coming every Friday. So you can meet me with me. You can show me anything if you have any specials to show me. Yeah. Friday, I'll be on campus. Yeah.
Okay, actually, sir, you have multiple classes on Thursday. Can I attend your lecture? Like I have a class from 3 to 5 maybe. So can I attend 1 to 3 class on Thursday if possible?
Yeah, I would say if you want to change sessions, so only Volkan Tunali can help you there. Please, Volkan is your
I
program.
emailed him, but he
Please email to Volkan will support you for this.
I emailed to Volkan sir, but he said that the timetable is scheduled by the automatically. So if you please allow me to attend your another lecture.
Yeah, if you want to show me anything, you can come Friday. No worry, I can help you. But you can just finish all the coursework, verbal presentation, bring on Friday. I can check. No problem. There is no problem. No one will resist you.
Excuse me, sir.
And make sure you need to join the schedule session. Let's say if you are going to change, others show they will going to change. Everything will be in trouble. This is centralized approach, definitely. But if there is some possibilities, you can ask your lecture program leader only. Yes, please. What's the next question?
Sir, attendance has been done automatically.
Yeah, all done 3 times. So if you can leave, definitely. Yeah, I have finished almost from all sides.
So is the next class?
Yes, so we are leaving now almost. So is there any important question? Let me know. Otherwise, I'm going to finish, please. Yeah.
Sir.
Yes, please.
Then my phone just switched off between lecture for 10 to 15 minutes. So I don't know whether my attendance was taken or not.
No, it's done. I have taken more than 3-4 times. So you must be there. Don't worry. Yeah? That's why I'm taking 3 times. Sir.
Okay.
No problem. Yeah. Okay, guys. So we are leaving. Hello, yeah.
Hello, sir. Yeah, I
Hello.
just joined 10 minutes back. May I know whether the attendance is calculated or not? Because I'm unable to join the link. I just messaged you in Teams.
Yeah,
I'm
no worries.
unable
So
to join the
if
link.
you join 10 minutes, 20 minutes late, so you are in attendance, don't worry. But make sure next time you need to be on time. Very, very important. Yeah. So you otherwise you will
Sure.
miss. No worry. Yeah, that's
Sure.
fine.
Yeah, thank you, sir.
Okay, guys. Don't worry, everyone. So please, I'm stopping awfully. So if there is anything we will discuss, don't worry. Start working on verbal presentation, please. Yeah. Okay, so I hope so you got everything. So please learn what we discussed, read the slides, what we discussed. It's super easy. There will be some class question in your class test. So we will schedule everything. Goodbye for now. And thank you so much for joining the session. Thank you so much for all cooperation and make sure you must engage very well every day, every week. Yeah. Bye for now. See you next week, hopefully. Yeah.
Thank you, sir.
Okay.
यार नेक्स्ट क्लास वाला लिंक किधर मिलेगा? Anyone?
भाई 1 मिनट रुक जाओ, मैं ढूंढ लेता हूँ, मैं भेजता हूँ.
Hello.
I'll sign in.
Is there anyone with MSc IT with cloud computing?
Yeah. Oh, select one.
Not in this class.
Not in this class.
हेलो
This
यार
class is
ये
specifically for
MSIT का
MSCIT
कौन सा नंबर
pathways.
का लेक्चर है अभी? हेलो
हाँ
यार मेरी जो एनरोलमेंट है वो लास्ट वीक हुई है, तो मुझे नहीं अभी पता कि ये जो लेक्चर था वो इस